Number 30 is about a boat being pulled to dock by a winch. As I picture the thing in motion, this right triangle, that's got to be a variable because that distance is changing, so I'll call it C. Um, the distance, the horizontal distance of the boat to the dock, I'll call X. And the height above from the deck to the winch, the vertical height, that's not going to change, so I'm going to call that 12. As the boat gets pulled closer, that's not changing. So my Pythagorean theorem is that guy. Let's see what they want to know about. So they want to, the winch pulls in a rope at a rate of 4 feet per second. So that's dc dt, because that's the rate at which the winch is pulling the rope. Determine the speed of the boat. So the speed of the boat is the rate at which x is changing. So I'm just going to go ahead and take the derivative of this. I think I have enough information. I have dc dt. I'm looking for dx dt. I can find x and c, hopefully. They got to tell me a time when, and they say when there's 13 feet of rope out. So they freeze it and say when c is 13. So there we go. I know that x is 5 by Pythagorean theorem when c is 13. dx dt is unknown. C is 13, and dc dt is, what was it? It's over on the side there, 4. Again, I'm not paying attention to units. I apologize. I'll leave that to you. 10 dx dt equals 2 times 13 times 4. Let's do that out. So that's 104. So then dx dt is 10.4. And that should be negative because the dc dt is also a negative rate because the rope's getting shorter. So that would make this a negative 4, which would make that a negative 104, which would make that a negative. So it's negative 10.4. That's the speed of the boat. Well, that's the velocity of the boat. The speed would be 10.4. So actually it depends on what they ask us. What happens to the speed of the boat? Determine the speed of the boat. So the speed is actually 10.4 because speed is the absolute value of velocity. So the speed is 10.4. The velocity is negative 10.4. And that is, what, feet per second? Yes. What happens to the speed of the boat as it gets closer to the dock? What do you think happens? It's going to slow down. I don't know. You just have to kind of picture it. You can also see the relationship in the related rates equation. I'm not going to spend too much time talking about that. Let's go on to part B. Suppose the boat is moving at a constant rate of 4 feet per second. So now they tell us that the speed of the boat is moving at 4 feet per second. Again, that's going to be negative because the distance x is getting shorter. But they're talking about speed, so they don't really care about the velocity or the negative signs, but we're going to keep track of them. Determine the speed at which the winch pulls in the rope. So we're looking now for dc dt when there's a total of 13 feet of rope out. So that's when c is 13. So it's the same equation up here. When c is 13, well, we know again that x will be 5. So you're plugging in the same stuff. It's just now the dx dt and the dc dt are switched. I know the dx dt. I'm looking for the dc dt. So I don't think it's that difficult. I'm not going to finish this out for you on here. I mean, you just have to plug in the numbers. You plug in a negative 4 here. You plug in a 5 here. You plug in a 13 here, and then you solve for this guy. So, I mean, that's some algebra there. I'm going to let you guys finish that one. I will tell you what the answer will be. So this, I'm going to look it up. This is number 30, and it's part B. So 30 part B is negative 20 over 13 feet per second. That's the DC, the rate of change of the rope. It's negative because the rope's getting shorter.